Hey, AP Statistics, and welcome to Chapter 1.2. Today we're going to talk about analyzing quantitative data. Right before we've been looking at categorical data, and now we're going to move on to something that's much more meaningful, and that is dealing with quantitative data. In fact, we're going to deal with mostly quantitative data from here on out. And then at the very end of the course, we'll come back and we'll look at a distribution called the chi-square distribution that allows us to make inferences for categorical data. So we're going to kind of move away from categorical data a bit and and then go into some ways to analyze quantitative data. We're going to look at dot plots and stem plots today. Pretty simple stuff. It's not too bad. We're going to do all this stuff. All right, so we're going to make a dot plot. We're going to draw a horizontal axis scale. It's not that hard. So this is an example of a dot plot, right? You'll see that what these are counts, right? We're counting the number of zeros, so there's only one zero in this distribution, and there it is. These aren't very difficult to create. Just remember, it's very important that you put a label here. If you don't, it's not right. Okay? Let's label your axis. Okay, so what do we want to do? When we are analyzing these, what we're looking for is when we're analyzing or describing a distribution, it says don't forget your socks, right? So what we need to do is we need to describe the shape, center, spread, and outliers. So I will go ahead and put this for you. So your socks, it's the S is for shape. O. The O is for outliers. We could also say some sort of extreme value because we don't know how to calculate outliers yet. So let's say it's an extreme value. You can't really say it's an outlier unless you have done the calculations to show that it is an outlier, and there are such calculations. C stands for center. So we want to describe, mean, median, depending on whether the distribution is skewed or roughly symmetric. And then the last one is a measure of spread. So another way to say it is, how much variability does the distribution have? Measures that we use for variability are interquartile range, which we're going to talk about in the next one, and standard deviation. Standard deviation, that is going to be something we talk about all year long. It's very, very important thing. And so when you're doing this, when you're asked to describe the distribution, you have to describe each thing. You have to describe the shape, whether there are any outliers or extreme values. Describe where the center is by either talking about the mean or median, and then spread when you talk about variability with IQR and standard deviation. So it's a good way to remember it. Just don't forget your socks. All right, so someone asked about IQR. This stands for inter. Wow, if I can spell. That stands for interquartile. Those are the most common ones that we'll use. That's what IQR is. You can also use just straight up range to describe your variability, but it's not as good. You'll really never do it. You would do that in like a basic statistics class, but not in this one. Oops. So that was basically that. Okay. Okay, so when you're describing shape, you have three options to describe the shape of the distribution. It is either going to be symmetric, roughly symmetric. Some of them are exactly symmetric, it depends. they'll be skewed to the right or skewed to the left. So this is what they look like. Here's some examples of these things. And for all of this, what we're doing is we're describing the shape of your distribution. So if it's roughly symmetric, you'll see that it's going to have, a mound shape with one high point trailing off the end. If it is skewed, so this one is skewed, and it doesn't. This one is skewed to the left. And the key is you want to look at where the tail is, right? This is also called a left-tailed distribution. And what you're looking at is where your tail is. If the tail's on the left, it's skewed left. If the tail's on the right, as this one is, then we'll say that it's skewed right. Your tail's over here. So if we're comparing two distributions, right? If it's saying compare these two distributions, then you need to compare everything in size, okay? So anytime you're being asked to describe a distribution, compare two distributions, you're being asked for size, okay? So in this case, if I was going to do this, right, don't forget your socks. For S, I would say South Africa appears to be skewed right, while the UK is roughly symmetric. So no, it doesn't appear. It's definitely. All right, and then I'll go through and I'll talk about outliers. UK has no outliers, right? It doesn't have any extreme values. Everything is grouped in there, right? What I'm looking for when I'm looking for an outlier or extreme value, something that doesn't fit the pattern, right? For instance, that one right there, right? We're talking about a household with over 25 people in the household. That's unusual, right? All right, UK has no no outliers. I'm going to say South Africa has one extreme value. See, at this point in time, we're just going to estimate center, right? But we would compare. I'm going to write just compare medians. We'll talk about that. And then for variability, I would just talk about this right away. We'll get into this. I don't like getting into doing this too in depth because we're missing some stuff, right? I would love to know the standard deviation of this. I would love to know maybe even interquartile range. It's interesting to compare these because one is skewed and one is symmetric, and we use different measures of center and spread depending on whether it's skewed or not. We'll get into that a lot more in the next lesson. It's kind of just getting us in there. This is where we need to do. What we really need out of this. We need a stem plot. You've seen it called a stem and leaf plot. That's a very nice way to quickly organize data that is not a dot plot. So it's pretty easy to make. It's pretty quick too. So we'll make these, analyze them. Basically, the gist of this entire lesson. So I'm going to go ahead and make a stem plot right now for you guys. We've got the responses of 20 female AP statistics students to the question, how many pairs of shoes do you have? 3. Dang.
All of these are too many.
You got a whole closet. It's like, this is my shoe closet. Well, aren't you special? All right. Oh, he has like a shoe room that like requires a ladder to get to like the ones. Yeah. Oh, we're talking about some take out shoes. I think that's a little bit. Oh, here we go. Let's do this. Let's do it. All right. So we're gonna make a stem and leaf plot, or a stem plot, as we call it. I'm gonna draw a line. Okay. On this side should always be only one digit, okay? You're just representing one digit on this side. This side can have more than one digit. And I'll show you how that works. I hope that I don't miss it. Right. All right. So we're going to go through this in sequence. I'm going to find the lowest value. It appears to be 13. Yeah. All right. So this right here, this is my stem. This is my leaf. Okay. In this case, this stem is going to represent the tens place, right? And over here on the right-hand side, I'm going to have the ones. So I have a 1. Okay. So everything that is in the tens, right, that is values of 10 plus up to 20. We're going to put in here, right? So I'm going to put a 1 and a 3. That's that one. Okay. So that is 13. I'm going to do, there's another 13 there, right? So I'm going to put another 3. So that says 13, 13. There's another 13. So this represents the 3 13s, right? There's 1 13, 2 13, 3 13. Over we go. We've got 15. So I'll put a 5, eh? There it is. That's right. So the reason why I say only one digit is what if they just had a ridiculous amount of shoes, like in the hundreds, right? So imagine I had a list like 100, 101. Now my stem would look like I could do 100 and then a 101, right? So this is that, right? And that's why I say it can only be one digit, right? Because I'm going to leave off this last digit. This is always the ones place, right? So these digits over here are always representing the ones place. Well, not necessarily if you're doing that, but you know what I mean? So that's why I say the same one digit. And we'll do one like that here in a minute to get used to different versions of it. We got 15, 19. We got everything that's 10, or less than 20. Yeah. All right. So now we'll go to 20. 22. I try to line these up nicely because it's easier to read. You're going to have to find things like median and quartiles from these. Much easier if they're really nice and lined up. So I did the 3 and I didn't mark it off. Oh, I know we have another one. That one. We got a 4. That's that one. We got a 6 and a 6. Nice. Those are those two. Nice. All right, a 3. 31. That's that one. Oh, cool. I missed 30. A 4. And anyway, that one. Next, no 40s. But even though there's not any 40s, I have to. Is there? Golly. Well, if there wasn't, I would still have to put the 4 here, right? And then I would just skip. do not go from 3 to 5, because that will be wrong. But there is a 40 minute. And for 50s, we got a 0, a 0, a 1, and a 7. Now, this is not done yet. Okay. The last thing you're going to do is you have to include a key. If you don't include a key, it's not right. All right. Your key is pretty simple. It just looks like this. You put it in a little box. You don't have to. It has to say key. And what you're going to say is in your key, you're going to pick out any value, right? Like this one, say 2/2. You're going to say what it means. It represents 22 shoes, 22 pairs. All right. We can also do one with split stems. So if we have males and females, we can split the stems, and we're going to make what's called a back-to-back stem block. So the way that this would work is like this. So I might put females here, and then males over here. And then we're going to have to start with 0 because we've got a lot of zeros. We've got a lot of people that have less than 10. It's probably a better way to put it. 10 pairs of shoes. We get 0, 5, 4, 5, 5, 6. Nope, there's another 5. Golly. These also need to be sequential as well. All right, we're going to want to go from least to greatest up. 5, 5, 6, 7, 7, 7, 7. Over here, none of these people have less than 10 pairs of shoes. Now we'll move over here. Is there an 8 for the girls? No. All right, there's an 8. Thank you. All right, so now we'll move on to 10 over here. Right, we have the 13, the 13, another 13. Oh. Right, and I'm going out from the middle. Right, so as we go out from the middle, we're increasing the values. 19. And then over here we have a 0, 0, 0, 0, 1, 2, 3, no. And so on. You get the idea, right? It would take a long time for her. This takes too much time for you to finish the whole thing because I'm going to do another example of this for you. So I don't want to spend all the time. I want to show you how you would split the stems, how that works. If you're going to split the stems to make a back-to-back stem. All right, so histograms. You have seen histograms. Be careful, right? These are not bar charts, right? Histograms apply to graphing data that is quantitative, while a bar chart is for categorical. Difference with between a histogram and a frequency graph is that a histogram has a bin width, right? So you might go from 0 to 5, and then you would list the number of the frequency of values in your data set that go from 0 to 5. They're not super easy. Just not great for our class, but I guess for some reason it needs to be. Yeah, there are so many better graphs. In fact, I would much rather see a box plot, which is what we're about.
Well, you're gonna like some.
Let's say it's a box. It's called a box and whisker plot normally. We're just gonna call it a box plot. I think.
That's the quarter one, right?
Yes. Yes.
Four times, nice.
Yeah. All right. This is an example of it. You have to choose appropriate bin widths, and then make the thing. I'm never gonna make you make one. I'm fairly certain. You'll have to interpret one at some point. But there's no point in having you make this thing. You'll never do it again all year. I try to stick to really trying to build foundations for what's coming, kind of leaving some of the fluffy stuff out. All right. And that's okay. This is all basically. Okay, cool. So we finished just the intro, right? Just talking about some vocabulary, introducing these things. So the next lesson is just going to use some examples of these for you. So look out for that coming up in the next lesson. Thanks for watching. Hope you're having a great day, and if you're not, I hope it gets better.